Hi, I'm Sharvil. I'm a software engineer at Fleet, and this is my talk on macOS visibility with Osquery and Apple's endpoint security framework. Let's dive in. I'll be covering some of the newer endpoint security stuff that I've been working on in Osquery and won't be covering Osquery itself in any detail here, but there are some amazing talks previously, which I highly recommend you check out to learn more about Osquery. There's a talk at 2018 MacDevOps by Zach Wasserman that kind of goes into that. In a nutshell, OSQuery is a cross-platform endpoint visibility agent. It presents a SQL interface and enables one to ask questions about your infrastructure and fleet at scale. So let's focus a little bit on some of those questions. We want to be able to answer questions such as who's adding things to my SSH known host or authorized keys files? Or who's copying my Chrome cookies or Chrome history? Or who's grabbing my iMessage history or 1Password vaults? Or who's writing to USB devices? Or who's modifying my Etsy host files? So these are some of the kind of questions that we want to be able to answer. But why do we want to be able to answer those questions? Well, it could be simply because of curiosity or compliance needs or malware analysis or intrusion detection or even light reverse engineering. So we want something like Little Snitch, a host-based application firewall, but for processes and files. Ideally, we want it for our entire Mac fleet with an option to move logs to a SIM for later analysis. So let's look at some prior art. Back in the day, there used to be a program called Little Flocker that I used. It was like Little Snitch, but worked on file operations. There's little info out here about it today, but it probably used Gauth and MacAF. Gauth is Apple's kernel authorization API, and MacAF is the mandatory access control framework. It used these to make policy decisions. Little Flocker was bought by F-Secure in 2017 and I believe discontinued soon after that. Uh, this approach works, but it requires us to be in the kernel, and Apple has deprecated Gauth, and Apple really wants developers out of the kernel, and I would argue for good reason. So what are some of the other approaches we could take to implement this? Well, there's dtrace, iosnoop, execsnoop. The problem with that is with the introduction of system integrity protection, Apple has kind of crippled dtrace. To use this approach, we would have to lower or disable our system integrity protection, and this is not really tenable, especially on workstations and production systems. So this is a no-go. What about FS events? FS events has a great API. We already have a file events table in OSQuery, but it lacks process context. While we can watch for files, we don't really know which processes have acted on it. And I would argue without that process context, this data is a little bit useless. So this is a no-go as well. So the next approach is OpenBSM and auditd. Unfortunately, Apple also deprecated OpenBSM recently. I think it's slated to be removed in future macOS versions. The current process events table in OSQuery uses this, but it has been plagued by performance issues. It's a pain to use. The syscalls are too low level and needs a lot of post-processing to get all the data. And if you have used it, you know how much of a pain that is. Uh, OpenBSM is also showing its age. I think this was introduced back in Snow Leopard. and I think Apple hired McAfee to contract this out to be part of common criteria. But this is a no-go as well. Based on OpenBSM, there was a cool little project called Xenumon a few years back. This, again, used an optional kernel extension and probably also used the KAuth APIs. Moreover, this project has been abandoned for a few years since the original author, Daniel, is now at Apple. In fact, working on endpoint security framework. If you take a look at this year's WWDC on it, Daniel is presenting on the newer stuff that they've introduced. So that brings us to Apple's endpoint security framework. It got introduced in macOS 10.15 Catalina. It's been continuously improved since. It's a C API that kind of ties everything together, is more performant. We won't go in depth on how endpoint security ties KAuth and related functionality together, but there are previous talks on it that I also highly recommend you check out if you're curious about it. So this brings us to Osquery and endpoint security. Much of this work started last year, and we shipped endpoint security-based process events table, the ES process events table, with Osquery 5.x late last year. This notifies on things like fork and exec and exit for processes. As a side note, Osquery will only support the notify type of events. We do not want to do any remediation or act on making decisions whether to allow or deny certain processes. So with the introduction of endpoint security in Osquery, this implementation required a lot of changes. Osquery was also going through a transition. We had to change out the certificates from Facebook to Linux Foundation. Osquery is a command line tool, so we had to figure out how to create a shim app bundle on top of it. We had to figure out packaging with provisioning profiles on it. We had to update the CI. We had to get the entitlements, get the code signing, notarization working. We had to automate it all. This was hard work because Osquery is cross-platform, written in C++, and uses CMake and not Xcode. So it's a little bit of, we had to figure our own path out. But this shipped late last year. It's used in prod, it's stable, and the response has been pretty great. Now we are expanding this with the ES process file events table. This will add support for notifying events on like create a file, write to a file, truncate a file, rename a file. There is planned support for other event types in the future. This ES process file events is slated to ship with Osquery 5.4, which should be pretty soon, hopefully. So let's look at some of the implementation details. I'll run through a little bit of high-level code on how we got here, what was required, how we get the data, how the eventing thing works a little bit in Osquery. So a little bit of a background, events-based table in Osquery, while it presents a SQL layer, they are backed by RocksDB. So whenever an event happens, it gets stored in the backing store, RocksDB, and it's there until it's expired or queried out. So Osquery has an eventing framework with the concept of a publisher and a subscriber. So here we create and register an endpoint security file event publisher. Since we do support older macOS versions, we have to do this built-in check, Clang attributes, to make sure this is only running on Catalina and above. So we set this up here. We similarly on the subscriber side set this up. We add the events we are interested in and have a callback to it. Next up, we set up the handler for the ES client. So this handler will be called every time we have a message from the endpoint security subsystem. This handle message here would process it, parse it, do what's needed based on the event type. Um, it will it will parse out the process details, the path details, the code signing hash, all that. It'll then create a row for the table in Osquery and batch them up so that it gets stored um, into the RocksDB database. So that's a quick high-level overview of how this is implemented. There's a lot of detail which I have to gloss over because it'll be kind of boring and lack of time. Let's look at a quick demo next. Here I'm copying my 1Password SQLite vault. So imagine like a malicious script somehow got local privilege on your machine and it's going through, your 1Password vault or your Chrome cookies or whatever. So here to replicate that, I'm just, copying it, by hand using CP. So on the left, which is what ES process file events table would show, like it shows you the file name that was written into it, shows the event type, it shows the path of the binary that got ran, and the corresponding exec event will be in the ES process events table, which is shown here on the right. It has a lot more data. You can check the PID on both. There's a whole command line, which will show you like the entire path. There's the current working directory. There's the code signing hash of that. There's a signing ID, who's running it, the UID, GID of it, whether it's a platform binary, and here we have the event type exec. So you can imagine how you can piece together answers to some of the questions we raised earlier using these two tables. And they'll be in your sim, and you can like correlate them later, analyze them later. Uh, yeah, and this is a quick demo of what's currently possible. But WWDC also happened last week, so let's take a very quick look at what that brings us. Excuse the pun here, but yeah, let's venture into more event types that got introduced. So we have new event types for authentication, login, logout, gatekeeper events, XProtect events, and data leak prevention events. So these are, login, logout with login window, with SSH, whenever screen share gets attached, detached. So those would be nice to have that in, and this will enable us to get this in the future when this ships. So yeah, that's a quick look at endpoint security stuff in Osquery. And I believe it takes a village to ship and build software, so it wouldn't be possible without the community and the users. It wouldn't be possible without the technical steering committee. A lot of this work started last year at Trail of Bits, so they've been a massive help. And Fleet, my current employer, which allows me to do this and work on this. Um, Here are some of the resources for documentation and GitHub repos. We also have Slack in MacAdmins, and we have Osquery Slack, so come say hi, come hang out. If you have questions, I'll be out in the Discord answering them. Here's my email and social, and that's my talk. Thank you for listening.